Have you ever just stopped on a clear, quiet night and looked up away from the city lights where the sky opens up into this vast dark ocean sprinkled with countless points of light? It's one of the most peaceful and profound experiences we can have. We feel small but also connected. You look up at the same stars that your ancestors did thousands of years ago. It feels immediate. It feels like you are seeing what is happening right now, millions of miles away. But the deepest secret of the night sky, the very first lesson of cosmology, is that you aren't. Looking at the night sky isn't like looking out your window. It's like looking at a photograph, an incredibly old photograph. In fact, it's the oldest history book in the universe. The key to understanding this is light itself. Light travels faster than anything else we know. It moves at an incredible speed, about 300,000 kilometers every single second. That's fast enough to circle the Earth more than 7 times in 1 second. It feels instant, doesn't it? You flip a switch and the room is bright. But in the context of the universe, this speed, well, it's actually quite slow. The universe is so unimaginably vast that even at this breakneck speed, light takes time to cross the distance. It takes time for the light from a star to travel across the emptiness of space and finally reach your eye. This means that when you look at any object in the sky, you're not seeing it as it is right now. You're seeing it as it was in the past. The further away the object is, the further back in time you're looking. The night sky is not a snapshot, it's a timescape. Every single light you see is an echo. Let's start close to home. The moon. It's our nearest companion and it's relatively close. The light you see bouncing off its surface is only about 1.3 seconds old. You're seeing the moon as it was just over a second ago. What about the sun? Never look directly at it, of course. The sun's about 150,050,000 kilometers away. It takes light about 8 minutes and 20 seconds to travel from the sun to us. This means if the sun were to suddenly just go out, we wouldn't know about it for 8 full minutes. We'd be living on borrowed time, completely unaware. Now, let's look at the stars. The nearest star system to us is Alpha Centauri. Its closest star, Proxima Centauri, is about 4.24 light years away. A light year isn't a measure of time, it's a measure of distance. It's the distance light travels in 1 year, a staggering 9.5,950,000 kilometers. So the faint light we see from Proxima Centauri tonight actually left that star 4.24 years ago. When you see it, you're seeing the star as it was when someone on Earth might have been starting their first year of high school. Let's go further. Find the constellation Orion with his famous belt. That bright fuzzy-looking star in his sword isn't a star at all. It's the Orion Nebula. It's a vast stellar nursery, a cloud of gas and dust where thousands of new stars are being born. It's beautiful, and it's about 1,340 light-years away. The light reaching your eyes tonight left the Orion Nebula around the year 685 AD. It was travelling through space during the early Middle Ages through the rise and fall of distant empires, all while humanity was building castles and sailing wooden ships. When that light began its journey, the Viking Age hadn't even started. Every star is a postcard from the past. Many of the stars you see might not even be there anymore. A massive star much larger than our sun might have exploded in a supernova 500 years ago. But if that star was 1,000 light years away, we still have 500 more years of normal light to receive before the light from that explosion finally reaches us. We are quite literally looking at ghosts. This idea that distance is time is the single most important tool an astronomer has. It means we don't need a time machine to study the past, we just need a telescope. When you look at the Andromeda Galaxy, our nearest major galactic neighbour, it appears as a faint fuzzy smudge to the naked eye. That smudge is 2.5 million to the 500,000 light years away. The light you are capturing in your eye left that galaxy 2.5 million years ago. At that time, modern humans, Homo sapiens, did not exist. Our early ancestors, like Homo habilis, were just beginning to use stone tools on the African savanna. And now we have built tools that are the most powerful time machines ever conceived. Telescopes like the Hubble Space Telescope, and even more so the James Webb Space Telescope, or JWST. These instruments are not just designed to see things that are far away, they are explicitly designed to see things that are ancient. They gather faint ancient light that has been travelling for billions of years. When the JWST looks at the most distant objects, it is not seeing the universe as it is today. It is seeing the universe as it was 13 billion years ago or more. Our universe is thought to be about 13.8 billion years old. So we are seeing the universe in its infancy. We are seeing the cosmic dawn, the very first galaxies and stars just beginning to switch on, emerging from the darkness after the Big Bang. We get to watch the universe grow up. We see toddler galaxies, chaotic and bright, merging and colliding. We see teenage galaxies and finally fully grown adult galaxies like our own Milky Way. We can piece together the entire story of cosmic evolution not by guessing but by simply looking. So the next time you stand under that dark sky, remember what you are truly looking at. You're not just seeing lights, you're receiving ancient messages. Every photon, every tiny particle of light that strikes your retina has travelled for years or centuries or millions or billions of years just to end its long journey with you. The night sky is a history lesson written in fire. It teaches us about scale, about time, and about our own small place in this vast unfolding story. We are standing on a tiny planet, looking out into an ocean of was. We are time travellers just by opening our eyes. We are connected to the birth of stars and the death of galaxies. That light isn't just illumination. That light is information. That light is memory. We have just spent a quiet moment reflecting on the deep, seemingly eternal river of time, the billions of years that have passed since the universe first flared into being. It's a journey that stretches our minds, forcing us to think in epochs, rather than minutes in eons, rather than lifetimes. But time, as vast as it is only one half of the story. The other half, the one that we see every time we look up into the dark, is space. We must move now from the when to the where, from the immense timeline of cosmic history to the staggering scale of the universe itself. If the age of the cosmos bends our perception, its physical size threatens to break it entirely. We are leaving the familiar shore of a long past and setting sail on the dark, endless ocean of the how big. The central challenge we face when we look outwards is one of basic understanding. Our minds, our human brains, are simply not built to grasp the numbers involved. We are creatures of the everyday. We evolved on the plains of Africa, not in the voids between galaxies. We understand what 3 means, 3 apples, 3 friends. We can comfortably visualize 100 a crowd of people. Even 1,000 is manageable. We can picture a small village or a large audience. But somewhere after that we hit a wall. The symbols still work, but the feeling for the number is lost. What does 1 million truly look like? We use the word so easily, but can we feel its weight? We can try. 1 million seconds is about 11.5 days. Okay, our minds can hold that. We can imagine waiting for something for 11.5 days. But what about a billion? How much bigger is it? Our intuition fails us. We think of it as just the next step up, like going from 100 to 1,000. But our intuition is profoundly wrong. A billion seconds is not a few months. It is not a year. A billion seconds is over 31 years. That is the trap. Our language uses similar sounding words million, billion, trillion, but the reality they describe is not a gentle slope. It is a vertical cliff. Each step is 1,000 times larger than the one before it. A million is 1,000 thousands. A billion is 1,000 millions. A trillion is 1,000 billions. We are trying to climb a mountain whose peak is lost in the clouds using only the tools we developed for walking on flat ground. And the universe in its quiet, grand indifference operates on the scale of trillions. To bridge this mental gap, we reach for analogies. We try to pin these ethereal, slippery numbers to something solid, something we can touch. And the most famous, most poetic analogy for the scale of the cosmos is the one about sand. Picture yourself on a beach. It doesn't have to be a specific one, just your idea of a beach. Feel the sun, hear the waves. Now bend down and scoop up a single handful of sand. Look at it closely. How many tiny grains are in your palm? A few thousand, 10,000. It's impossible to count, but you can feel their collective weight, a tiny patch of ground. Now look at the beach you are on. Look left, look right. The sand stretches on perhaps for miles, a wide, deep ribbon of countless grains. Imagine counting every single grain on this beach. It's a task that would take a lifetime. It is utterly impractical, but in principle it's a number. We can imagine that number even if we can't say what it is. But we are not finished. The saying isn't one beach. The saying is all the beaches on Earth. Stop and think about that. Think about every coastline on every continent. The entire coast of Africa. The vast shores of Australia. The thousands of islands in the Pacific, each with its own ring of sand. The coasts of North and South America. The hidden coves of the Mediterranean. Think of all the sand. You can't see the sand that makes up the vast deserts like the Sahara or the Gobi, which are really just inland oceans of sand. Combine all of it, every grain from every beach, from every desert on the entire planet. It is a number so colossal that it ceases to be a number and becomes a concept, the total. It feels like the biggest possible number we can connect to a physical object on our world. And here is the punchline, here is the moment of cosmic vertigo. There are more stars in our observable universe than there are grains of sand on all the beaches and in all the deserts on planet Earth. We try to put actual figures to this to replace the poetry with arithmetic. The estimates change as our telescopes get better, but the current conservative consensus is staggering. Scientists now believe that our observable universe, the part we are physically capable of seeing, contains roughly 2 trillion galaxies. Let's pause on that number. Not 2 billion, 2 trillion. That is a 2 followed by 12 zeros, 2 million million. A galaxy, remember, is not a star. A galaxy is a massive spinning island city of stars. Our own galaxy, the Milky Way, is our home city. It is a vast, beautiful spiral, and it contains, by current estimates, somewhere between 100 billion and 400 billion stars. Our Sun is just one single average unexceptional star among hundreds of billions in one average unexceptional galaxy. And there are 2 trillion of these other galaxies. If we take the low-end average, let's say just 100 billion stars per galaxy, and multiply it by 2 trillion galaxies, the number simply breaks our language. It's a 2 followed by 23 zeros, 200 sextillion. Or to put it in a way that is just as meaningless but sounds more impressive, 200,000 million. The grains of sand analogy, as vast as it was, barely even comes close. We have profoundly underestimated the sand, and even then the stars win. It isn't even a close race. These numbers do more than just exceed our perception. They challenge our very sense of self, our idea of importance. To stand under a truly dark, clear sky, far from city lights, is to be confronted by this fact. Every tiny pinprick of light you see, every star in every constellation is a sun, many of them just like ours, many of them likely orbited by their own families of planets, and all of them, every single star you can see with your naked eye, are just our closest neighbours. They are all part of our local neighbourhood within the Milky Way. We cannot even see the other hundreds of billions of stars in our own galaxy, the faint milky band that gives our galaxy its name, that is the blended collective light of billions of distant, unresolved stars from our own galactic core, their individual fires blurring into a pale celestial cloud. And the other galaxies, with our eyes alone, we can see only 1 or 2 which appear as tiny, faint, fuzzy smudges. That faint smudge, the Andromeda Galaxy, is an entire other city of 1 trillion stars far larger than our own, and it is the closest major galaxy to us. So what does this mean? What do we do with this information? It is a kind warning of cosmic vertigo. It is a feeling of being unimaginably, profoundly and completely small. If you were to take the entire history of human civilization, every king, every war, every poem, every symphony, every act of love and cruelty, and place it against this backdrop, it vanishes. Our entire world, our precious blue-green dot, is less than a single grain of sand in a desert that stretches beyond all horizons. This realization can be terrifying. It can feel like a cold existential dread. It can make everything seem pointless. But it can also be something else. It can be liberating. It can be a source of profound, humbling awe. We are small, yes, but we are also part of this. We are made of the exact same material as those distant blazing stars. And for a brief flickering moment, we are the part of the universe that has woken up. We are the cosmos looking back at itself and trying with our tiny minds to count the sand. When we gaze out at that ocean of light, that galaxy of ours, which is itself just one island in an endless cosmic sea, we are forced to make a simple logical leap. For a long time we looked at our own solar system and wondered if it was a miracle. We saw our sun a steady, modest star, and our planet Earth, a blue marble of impossible beauty and balance. We assumed this setup must be rare. We thought that perhaps planets themselves were a cosmic accident, a fluke in the grand design. But in just the last few decades our eyes have opened. We have built new telescopes, instruments of incredible precision, capable of detecting the tiniest wobble of a distant star or the faintest dimming of its light as a shadow passes in front of it. And what we found has changed our perspective forever. It turns out the universe is obsessed with making planets. It's what stars do. We now know with a high degree of confidence that most stars have planets. It is not the exception, it is the rule. The galaxy is teeming, absolutely overflowing with solar systems. As we look closer, we find more and more planets in what we call the habitable zone. This is that perfect Goldilocks distance from a star not too hot so water boils away into steam, not too cold so water freezes into a world of solid ice. It is the place where the temperature is just right so that liquid water, the very solvent of life as we know it, could pool on the surface. Let's pause on that idea. We are not talking about a few dozen. We are not talking about a few thousand. When you do the math based on the data we already have from just our tiny corner of the galaxy, the estimates are staggering. There could be tens of billions of planets similar in size to Earth orbiting in the habitable zones of their stars in our galaxy alone. Billions of Earth-like worlds. And if you extend that math to all the trillions of other galaxies we can see, the number becomes quite literally astronomical. We are talking about trillions upon trillions of potential homes for life. The universe, it seems, is practically shouting with potential. It has run the experiment of life not just once, but perhaps quadrillions of times over. And this is where this great quiet sets in. This is where the profound and perhaps unsettling question arises. Our star, the Sun, is about 4.5 billion years old. Life on Earth took its time, but we eventually arrived at intelligence at Curiosity at radio telescopes. But our Sun is a relative newcomer. The universe is over 13 billion years old. There are stars in our galaxy that are far older than ours, billions of years older. If a civilization emerged on a planet around one of these older stars, say just 1 billion years before us, what would they be like today? A civilization with a 1 billion year head start. Think about our own technological progress in just 100 years. We went from horse-drawn carriages to landing robots on Mars. We went from the first simple radio broadcast to sending messages into the deep void. A civilization that was just 1,000 years more advanced than us would seem like magic. 1 million years, unthinkable. 1 billion years, they would be as gods to us. Their technology would be indistinguishable from the laws of physics itself. They could presumably travel between the stars with ease. They could harness the energy of entire suns. They would, you might assume, have explored and perhaps colonized vast sections of the galaxy. And yet we see nothing, we hear nothing. This is the great dilemma, the question posed by the physicist Enrico Fermi over lunch one day. If the math says the universe should be full of life, full of civilizations, where is everybody? This is the Fermi paradox. It is the stunning contradiction between the high probability of life existing and the total, deafening, absolute silence that greets us every time we point our telescopes to the sky and listen. Where are they? There are, of course, many possible answers. None of them are fully satisfying, and all of them make us pause and think. Perhaps the simplest answer is the most brutal. The distances are just too vast. The galaxy is 100,000 light-years across. Even travelling at the speed of light, the ultimate speed limit of the universe, it would take 100,000 years to cross from one side to the other. Maybe interstellar travel is just too hard, too expensive, or too dangerous for any species, no matter how advanced. Maybe everyone is trapped in their own solar system, just as we are broadcasting messages that will take millennia to reach their nearest neighbour. Or perhaps the barrier isn't space but time. This is a more chilling idea, often called the Great Filter. This hypothesis suggests that all technological civilizations eventually destroy themselves. Perhaps it's nuclear war, or uncontrollable climate change, or a runaway artificial intelligence, or a genetically engineered pandemic. Maybe this is the destiny of all intelligent life, to flare up brightly for a brief, glorious moment only to extinguish itself just as it reaches for the stars. In this view, we look at the silent sky and see not an empty galaxy, but a graveyard. We might be the first, or more frighteningly, we might be the last, the only ones who have so far survived our own technological adolescence. But there are other less grim possibilities. Maybe they are out there, but they are deliberately hiding. This is the dark forest idea. Perhaps the galaxy is a dangerous place, and the first rule of survival is to remain quiet. To broadcast your existence is to invite predators, beings far older and more powerful than yourself. So everyone is listening, but no one is transmitting. Or perhaps in a more optimistic view, they are simply different. We are looking for radio signals. We are looking for great engineering projects. We are looking for things we would do. What if a billion-year-old civilization has moved beyond physical form? What if they live in vast digital simulations or in the quantum foam of space-time itself? What if they are so advanced that we are to them completely uninteresting? Think of an anthill in the middle of a field. We humans might walk by. We might even stop and look at it for a moment. But we do not try to communicate with the ants. We don't try to teach them calculus or show them our art. Their reality is completely separate from ours. We are not a threat to them, but we are also not peers. We just are. Maybe we are the ants, and the galactic super civilizations are all around us simply going about their business, operating on a level we cannot even begin to perceive. Or maybe the simplest answer is the truth. Maybe we are after all alone. Maybe the long, complex chain of events that led to us, the right star, the right planet, the right moon, the right chemistry, the accidental spark of life, the billions of years of evolution from a single cell to a creature that can look up and ask, why so impossibly rare that it only happened once right here. We don't know the answer, but the silence itself is a kind of data. It is a profound and empty canvas. When we look at the stars, we are not just seeing light, we are listening to the quiet. This silence of the cosmos is just as profound, just as vast, and just as humbling as its scale. It forces us to look back at ourselves at this one tiny, fragile, impossibly beautiful world. It suggests that whether we are one of many or one of one, what we have here is precious beyond measure. The quiet continues, and so we listen. We've spent so much time looking out, listening for a signal, searching for a planet, wondering if there is a they or an it somewhere in the vast, silent darkness. It's a noble search born from our deepest curiosity. But what if the most profound connection we've been looking for is not out there at all? What if the most stunning revelation about our place in the universe is right here inside us? Let's pause that outward search for just a moment. Let's turn our gaze inward, not just into our minds and our thoughts, but into the very substance of our bodies, into the atoms that build our cells. You have almost certainly heard the phrase, "we are stardust." It sounds beautiful, doesn't it? Poetic, like something from a song or a hopeful philosophy. But the truth is, this isn't poetry. It is one of the most concrete, literal, and scientifically accurate statements we can possibly make. You and I, the cats sleeping on the chair, the tree outside the window, the very ground we walk on, we are the children of the stars. We are built from the ashes of long-dead suns. Our connection to the cosmos isn't just philosophical, it's physical. It's written in our DNA, it's flowing in our blood, it's holding up our bones. To understand this, we have to go back to the very beginning. In the first few minutes after the Big Bang, the universe was an incredibly hot, dense soup of pure energy and the simplest particles. As it expanded and cooled, the very first atoms began to form. But the universe in its infancy could only create the lightest, simplest elements. Almost all of it was hydrogen with a good amount of helium and just the faintest, tiniest trace of lithium. And that was it. Imagine trying to build our world with only hydrogen and helium. Imagine trying to build a person. You can't. They are the simplest building blocks, but you need more. You need the complex, heavy, and versatile stuff. You need carbon, the atom that can build the long, intricate chains that form the backbone of all life as we know it. You need oxygen to hold hands with hydrogen and create water, the solvent of life. You need nitrogen, calcium, phosphorus, sulfur, and iron. None of these existed in the beginning. So where did they come from? They had to be made. They were cooked. They were forged. The universe in its infinite patience created giant cosmic factories designed for one purpose: to build the rest of the elements. We call these factories stars. Our very own sun right now is one of these factories. Deep in its core, the pressure and temperature are so immense, millions of degrees, that it is violently smashing hydrogen atoms together to make helium. This process, called nuclear fusion, is what releases the light and heat that stream across space and warm our planet. It's the engine of the star. For a star the size of our sun, that's pretty much where the story ends. It will fuse hydrogen for 10 billion years, and then in its old age, it will briefly fuse helium into carbon and oxygen. But it doesn't have enough mass, enough gravitational power to go any further. It will eventually retire gently, puffing off its outer layers to create a beautiful planetary nebula, leaving behind its small, dense core. But the universe in its grand design needed more. It needed the really heavy stuff. And for that it uses its most dramatic and powerful tools: massive stars. Stars that are 10, 20, 50 times more massive than our sun. These giants live fast and they die young, burning through their fuel in a cosmic flash. Their cores are so much hotter, so much denser. They don't just stop at helium. Once they run out of hydrogen, they begin fusing helium into carbon. When the helium runs low, they crush the carbon to make oxygen. Then they fuse oxygen into neon into silicon, and on, building heavier and heavier elements in a series of concentric onion-like layers in their core. They create magnesium, sulfur, phosphorus, all the way up to iron. Iron is special. Iron is the end of the line. For all the elements leading up to it, the act of fusion released energy pushing outward and holding the star up against its own crushing gravity. But when a star tries to fuse iron, the process doesn't release energy, it consumes it. For the star, this is a catastrophe. The energy furnace at its center, which has supported it for its entire life, suddenly and completely turns off. With nothing to hold it up, the star's immense gravity wins. In less than a second, the entire star collapses in on itself, moving at nearly a quarter of the speed of light. This catastrophic collapse rebounds off the star's new impossibly dense core, triggering the most violent and powerful explosion in the entire universe, a supernova. This explosion is so bright it can temporarily outshine an entire galaxy of billions of other stars. And in that unimaginable flash of energy and light, two critical things happen. First, all the elements the star cooked during its long life, all that precious carbon, oxygen, nitrogen and iron are blasted out into deep space, scattered across light years. Second, the explosion itself is so incredibly energetic that it provides the power needed to create all the other elements, the ones heavier than iron that the star could never make in its core, the silver and gold in your jewelry, the copper in your pipes, the iodine in your thyroid, the uranium that powers reactors. Every last atom of these heavy elements was born in the final dying scream of a massive star. This is not just a distant abstract story. This is our story. This cloud of star stuff, this cosmic debris rich with carbon and iron and gold drifted through space for eons. It mixed with the remnants of other supernovae from other dead stars, becoming a rich cosmic stew. Eventually, billions of years later, gravity began to pull a piece of this magnificent recycled cloud together. It swirled, it flattened into a disk, and at its center it ignited. A new star was born, our sun, and the leftover bits of dust and gas in that swirling disk, they clumped together. They formed pebbles, then rocks, then boulders, then worlds. They became Mercury, Venus, Mars, Jupiter, and our Earth. That is why we are here. The Earth itself is a collection of second-hand stardust, and every single living thing on it is too. The calcium that makes your bones strong enough to hold you up was forged in the core of a star. The iron atom at the very center of each hemoglobin molecule in your blood, the atom that catches the oxygen you breathe and carries it to your cells. That iron atom was created in the heart of a giant star just moments before it exploded. The carbon that forms the complex, beautiful chains of your DNA, the very blueprint of you, was fused from lighter elements billions of years ago in a star that lived and died long before the Earth was even a thought. Think about that. Take a deep, slow breath. The oxygen you just inhaled was likely created inside a star. The nitrogen in that same breath also stellar. You are quite literally breathing the ghosts of ancient suns. So you see, we are not separate from the universe. We are not just living in the cosmos as if we are visitors in a foreign land. We are the cosmos. We are a piece of it. We are a way for the universe to experience itself. That deep sense of wonder you feel when you look up at the night sky, or that curiosity about where we came from and where we are going, that is the universe itself wondering. When you learn about the stars, you are the universe learning about itself. When you feel joy or sadness or a profound sense of connection, that is the universe feeling. We are the consciousness of the cosmos made manifest. We are stardust that has come to life, evolved over billions of years, and finally begun to contemplate its own origins. There is something profoundly comforting in this. It means we are not an accident. We are not aliens lost on a hostile rock. We are a fundamental, intrinsic part of this entire grand unfolding story. We are made of the same material as the most distant galaxies and the most brilliant nebulas. We belong here. We are in the deepest and most literal sense possible home. We've spent so much time looking up, haven't we? We've traced our atoms back to the hearts of dying stars. We feel that cosmic connection, that sense of being a part of this vast, silent universe. It's humbling and it's magnificent. But there is another connection just as profound that we often overlook. It's not in the sky, it's right here on this planet all around us. It's in the grass, in the birds, and even in the fruit bowl on your kitchen counter. I'm going to tell you a fact that sounds like a joke, but it is 100% true, and it is one of the most important facts you will ever hear. You right now as you share about 50% of your genes with a banana. Go ahead, laugh. It sounds absurd. A person capable of building cities, writing poetry, and wondering about the cosmos, and a soft yellow fruit. What could we possibly have in common? It seems impossible, but this single strange fact unlocks one of the deepest secrets of life. When we say 50%, we're not saying that half of your body is secretly a banana. We're talking about our instruction manual, our DNA. DNA is the code, the blueprint for building a living thing, and genes are the specific instructions in that manual. An instruction might say, build a protein to get energy from sugar, or build a protein to repair a broken part of the cell. It turns out that all life on Earth solved the most basic problems a very, very long time ago, and then stuck with the solution because it worked. How do you break down sugar for energy? How do you copy your instructions? How do you get rid of waste? How do you manage the basic functions of a living cell? The genes that handle these core tasks are called conserved genes. They are conserved because they have been protected and passed down almost unchanged for billions of years. They are the housekeeping genes doing the fundamental jobs that every living thing needs to do, whether it's a yeast, a whale, a human, or a banana. That 50% we share with the banana. It's mostly these ancient essential instructions. We both need to manage our cells, get energy, and repair ourselves. We just use those instructions to build very different looking houses. This shared codebook points to an inescapable conclusion. All life on Earth is related. We all come from a single common source. Scientists call this the last universal common ancestor, or LUCA. This wasn't the very first living thing, but it's the ancestor from which all life that exists today descends. Billions of years ago, this humble organism or community of organisms had figured out the basics. It had the core operating system, and it passed that system on to its children. Think of life on Earth as a single ancient operating system like Windows or Mac OS, but written in the language of DNA. This OS handles all the essential background tasks, then evolution starts writing different apps to run on top of it. A banana is an app for being a plant. It has specialized code for things like photosynthesis, turning sunlight into food and growing a protective yellow peel. A human is an app for being a mammal. We have specialized code for things like building a complex brain, walking on two legs, and regulating our own body temperature. But underneath, we are both running that same core operating system. The app part of our code is what makes us look so different. The operating system part is what makes us and the banana and the fly on the wall and the bacteria in the soil all life. We are all variations on a single ancient theme. This completely changes how we should see ourselves. For a long time, we've had this idea of a ladder of life. At the bottom are the simple things like slime, and then you climb up through plants and insects and fish and reptiles until you get to the very top. And there we are. Humans. The pinnacle. The goal of it all. This is fundamentally wrong. It's pure ego. The truth is infinitely more beautiful and more humbling. Life is not a ladder. It is a tree. An immense, ancient, sprawling tree with millions and millions of branches. This tree has been growing for nearly 4 billion years. Most of the branches have died off. The ones that are left are all the species alive today. We humans are not the top of the tree. We are one tiny twig on the very end of one small branch. The banana is another twig on another branch. The chimpanzee is a twig on a branch right next to ours, which is why we share 98% of our DNA with them. The mushroom is on another branch entirely. The bacteria that started it all are not the bottom. They are the massive ancient trunk and roots that the whole tree depends on. We are not the point of the tree, we are simply one of its many, many current expressions. The banana is just as evolved as we are. It has just been evolving to be a really successful banana while we've been evolving to be a really successful primate. When you look at a forest, you don't see a ladder. You see a complex, interconnected system. You see a family. That is what life on Earth is. The banana is your distant cousin. The bird at your window is a closer cousin. The stardust built our bodies, but this ancient code, this shared operating system from LUCA, is what connects us. We are in the most literal way possible one great sprawling family. We are not above nature looking down. We are nature. We are a part of this grand living, breathing whole, a single expression of life's incredible multi-billion-year-old experiment. We have spent this time together contemplating life, that intricate, fragile, and perhaps inevitable dance of chemistry. It feels so specific, so precious, and so very temporary. But the universe doesn't just build things that are temporary, it also builds extremes. It forges structures that seem to defy the very concept of changes, things that speak to the other side of existence, finality, and perhaps eternity. When we look up past the cozy cradle of our solar system, we are searching not just for life, but for the very limits of reality. We are looking for the absolute. And in that search, we invariably find the monsters. We find the symbols of the end. We've spent time thinking about gravity, that immense patient force that pulls everything together. We've looked at its ultimate expression, the black hole, a point of such incredible density that it becomes the final destination, the endpoint of matter. It's the universe's great organizer, the sculptor of galaxies, the force that holds our feet to the ground. It feels like the dominant power, the one running the show. But what if it's not? What if, while we were all watching gravity pull things together, there was another force, a hidden influence doing the exact opposite, a force pushing things apart? For most of the 20th century, the biggest question in cosmology was about the fate of the universe. We had known since the 1920s, thanks to Edwin Hubble, that the universe was expanding, galaxies were moving away from each other. The great debate was simple gravity. We know gravity pulls things together, so surely this expansion must be slowing down. The only question was how much. Would gravity eventually win, stop the expansion and pull everything back together in a big crunch? Or would the expansion just slow down but coast forever, leaving a cold, empty future? In the late 1990s, two teams of astronomers set out to answer this question once and for all. Their plan was brilliant. They would use standard candles, a specific type of exploding star, a Type 1a supernova. These stellar explosions are special because for reasons of physics they always explode with almost the exact same predictable brightness. Think of it this way. If you see a row of 100-watt light bulbs stretching into the distance, you know how bright they should be. By measuring how dim they appear, you can calculate exactly how far away they are. These supernovae were their 100-watt bulbs for the cosmos. The astronomers pointed their telescopes at the deepest, oldest parts of the universe. They were looking for these ancient explosions. Their hypothesis was clear. They expected to find that the very distant supernovae were brighter than they should be, meaning the universe was expanding faster in the past and had slowed down since. They found the exact stunning opposite. The distant supernovae were dimmer than expected. They were fainter. This could only mean one thing: they were farther away than the models predicted. For them to be farther away, the expansion of the universe couldn't have slowed down. It must have at some point in the last few billion years sped up. This was discovery that broke physics. It was like throwing a ball into the air and watching it, instead of slowing down and falling, suddenly accelerate and shoot into the sky faster and faster. The universe is not just expanding, its expansion is accelerating. Something is pushing its foot down on the cosmic accelerator pedal. So what is it? What is this mysterious, invisible force that is pushing the entire universe apart? We gave it a name, but it is perhaps the most honest name scientists have ever given to a mystery. We call it dark energy. This name is quite literally a placeholder for our ignorance. It's dark not because it's sinister, but because we cannot see it. We cannot detect it. We cannot taste it or touch it. It doesn't interact with light or matter. We only know it exists because we can see what it's doing to everything else. It is energy, because it's the only way our models can describe a force that adds momentum to the system rather than taking it away. It is an anti-gravity, a repulsive force woven into the vacuum of space itself. And here is the most humbling and frankly terrifying fact of all. When we do the math, when we add up all the stuff in the universe, all the stars, all the galaxies, all the dust, all the black holes, all the normal matter that you and I are made of, it only accounts for about 5% of the total budget. Another 27% or so is dark matter, a different mystery we still haven't solved. The rest that leaves 68%. 68% of the known universe is dark energy. The vast majority of reality, the dominant force shaping the future of the cosmos, is something we cannot see and do not understand. The leading theory is that this energy isn't a thing in space like a cloud of gas. It is a property of space. It is built into the very fabric of the vacuum. And as space expands, more space is created. And since this energy is a property of space, more of this energy is created. This creates a terrifying feedback loop. More expansion means more space. More space means more dark energy. More dark energy means more push. More push means more expansion. While gravity gets weaker with distance, this dark energy gets stronger as the universe grows because there is simply more of it. It is winning. This discovery completely rewrote our understanding of the future. It gives us two possible and profoundly bleak endings. The first and most likely is the heat death, or the big freeze. If this dark energy is a constant steady push, the expansion will just keep accelerating. Over billions of years, the galaxies we see tonight will be pushed further and further away. They will cross a cosmic horizon, their light stretched so thin it will never be able to reach us again. They will vanish from our sky. Eventually our own local group of galaxies will be torn apart. The night sky will go black. The universe will become an infinitely vast, cold, dark and empty expanse, populated only by the dead cinders of stars and exhausted black holes, separated by distances so large they are meaningless. There is another more violent possibility. What if the dark energy isn't constant? What if it increases in strength over time? This is a theory called phantom energy. If this is true, the future is not a slow fade to black, but a violent end, the Big Rip. In this scenario, the accelerating expansion would become so powerful it would overcome all the other forces. First, it would rip galaxies apart. Then it would overcome the gravity holding solar systems together. Planets would be torn from their stars. Then the force would grow strong enough to overcome the electromagnetic bonds holding matter together. Planets, stars, and any life on them would be torn to pieces. Finally, in the last fractions of a second, the force would be strong enough to rip atoms themselves apart. The very fabric of space and time would be torn to shreds. We don't know which, if either is true. Current data leans toward the slow cold Big Freeze, but the realization is what matters. We have spent our entire history studying that 5% of the universe. We were so proud of what we'd learned. And yet the greatest discovery of our time is that 95% of reality is dark, completely beyond our current comprehension. Ancient map makers, when they drew maps of the known world and reached the edges into the unexplored oceans, would write, "Hic sunt dracones." Here be dragons. It was an admission of the unknown, of the vast mystery that lay beyond. We are in that moment right now. We have looked at the map of our universe and have been forced to write "Here be dragons" over 68% of it. We are floating on a tiny illuminated raft of understanding in the middle of a vast, dark, cosmic ocean. And that ocean is accelerating, pulling away from us in all directions, driven by a mystery we have only just begun to name. We have spent so much of our journey together looking out. We have stared into the deep past at the very edge of the observable universe. We have watched galaxies collide, and we have zoomed into the strange, fuzzy world of the quantum, the very building blocks of reality. But now we must make the most dramatic shift of all. We are going to turn the telescope around. We are going to stop looking out there and start looking in here. Because the single most complex, mysterious and powerful object in the known universe is not a star or a black hole or a nebula. It is the 3-pound universe of soft tissue resting behind your eyes, the brain. We are all walking around with this masterpiece of biology, and it didn't come with an instruction manual. We get detailed guides for our cars, for our kitchen appliances, for a new piece of software. But for the very thing that perceives, creates, and experiences our entire reality, we are just given it, and we have to figure it out as we go. Let's try for a moment to grasp the sheer scale of this inner cosmos. Your brain contains approximately 86 billion neurons. That is billion with a B. For context, we estimate there are perhaps 200 or 300 billion stars in our entire Milky Way galaxy. You are carrying a galactic-sized population of these processing cells inside your head. But the neurons themselves aren't even the main story. The story is the connection. Each one of these 86 billion neurons can reach out and form connections with thousands of other neurons, creating a web of pathways that is almost beyond human comprehension. The total number of these connections or synapses is estimated to be around 100 trillion. Let me say that again, 100 trillion. That is a number so vast it's difficult to picture. It is more than all the stars in 1,000 Milky Way galaxies. It is a network of complexity that dwarfs anything humanity has ever built, and it all fits in a space you could hold in your 2 hands. And here truly is that the most baffling part. This biological supercomputer, this galaxy of thought that is currently processing these words, calculating the space between you and the screen, remembering what you had for breakfast and managing your breathing all at the same time. It runs on about 20 watts of power. 20 watts! That is less energy than the dim light bulb inside your refrigerator. Your laptop needs more power than that just to browse the internet. Our most advanced supercomputers fill entire warehouses and require their own power plants to run. Yet the brain accomplishes tasks those computers can't even dream of, all while using the energy of a faint light. It is an impossible, beautiful miracle of efficiency. But the hardware, the numbers, the cells, that's the part we're beginning to understand. The real mystery, the part that keeps scientists and philosophers awake at night, is what this machine does. It creates you. What we call consciousness, this feeling of being alive, this awareness that you are you and not someone else. This rich internal movie that is playing for you right now is the greatest puzzle of all. We know with certainty that this feeling is just the tip of the iceberg. Your conscious mind is like the CEO of a massive corporation who only gets a simplified summary report. You're aware of the final decision, the final thought, the final feeling. But underneath that awareness, a million processes are running. Your brain is filtering the hum of the room, regulating your heartbeat, managing your body temperature, translating the light hitting your retina, all of it happening under the hood without you ever having to think about it. The you that you are aware of is just the final polished product. And what about memory? We speak about it so casually. We store a memory. We retrieve a file. But the brain isn't a hard drive. Memory isn't a single file tucked away in a folder. A memory is an act of creation. When you remember your childhood home, your brain isn't pulling up a photograph. It is rebuilding the experience, firing a pattern of neurons across all its different sections. It relights the visual cortex for the color of the paint. It activates the olfactory center for the smell of the kitchen. It fires the emotional centers for the feeling of being there. This is why memories are so fragile, why they can change and fade. They aren't files, they are performances restaged every single time you call them to mind. And then there are dreams. Every night we plug this impossible machine in to recharge and it goes gloriously haywire. It builds entire worlds from nothing. It replays our deepest fears, fulfills our unspoken wishes, and mashes up people, places and times in ways that are both profound and utterly nonsensical. What is this nightly theatre? Is it just the brain cleaning up its files? Is it sorting through the day's experiences? Or is it the mind telling itself stories in a language we have forgotten how to speak? For centuries we have been fascinated by the idea of the ghost in the machine. This idea, this feeling that you are a separate thing. A soul, a pilot, a spirit just sitting in the command chair of your brain, pulling the levers and watching the screen. But the more we learn about this labyrinth, the more we are pointed toward a much more radical and in many ways more beautiful conclusion. There is no ghost. You are not in the machine. You are the machine. You are the 86 billion neurons. You are the 100 trillion connections. You are the silent 20-watt electrical storm. Everything you are, your greatest joy, your deepest grief, your sense of humor, your fears, your quiet hopes, is written in this biological code. This isn't a cold or empty thought. To me, it is the ultimate wonder. It means that we, this collection of cells, this matter forged in the hearts of stars, have somehow organized ourselves to a point of such impossible complexity that we can feel, we can think, we can love. From this raw biology, music emerges. From these chemical signals, poetry is born. This machine can stop what it is doing, look up at a sunset, and feel a sense of awe. We are a piece of the universe that has become complex enough to turn around and ask, what am I? We are the cosmos made aware. And the engine of all of it, the source of our entire world, is this labyrinth we carry within. We often think of ourselves as a single contained being, this mind, this body, this me. We've talked about the brain in our head, that complex center of consciousness. We've even touched on the second brain in our gut, that network of nerves that manages the complex business of digestion and sends feelings up to our head. But we need to go deeper to a level that can feel almost alien at first, but is in fact the very definition of life as we know it. Let's start with a simple, staggering fact. If you were to count every cell in and on your body, you would find that the cells with your human DNA are in the minority. By some estimates, they are outnumbered 10 to 1. So, who are all the others? They are bacteria, they are fungi, they are archaea, they are viruses, an invisible, teeming, vibrating world of life that lives on your skin, in your mouth, and most of all in your gut. This is your microbiome. For a long time we thought of these things as germs, as invaders to be eliminated. But we are slowly, profoundly learning that this is not a story of us versus them. This is a story of we. These microorganisms are not squatters. They are residents. They are an organ as vital as your liver or your lungs. They have been evolving with us, shaping us for millions of years. And they are not sundant passengers. This is where we go beyond the second brain of our nerves and into something even more intricate. Your gut microbiome is a massive living chemical factory. These tiny beings digest parts of our food like certain fibers that our human cells simply cannot break down. And in doing so, they produce a vast orchestra of chemicals. They create vitamins, they create hormones, and they create something called neurotransmitters. These are the exact same chemicals that your brain cells use to talk to each other. Chemicals like serotonin, which is deeply linked to mood and happiness. Chemicals like dopamine linked to reward and motivation. A huge portion of your body's serotonin isn't made in your brain, it's made in your gut by these bacteria. And those chemicals don't just stay in the gut, they send messages. They communicate directly with your brain through a massive nerve called the vagus nerve, a sort of data superhighway running from your brainstem to your abdomen. This is the gut-brain axis. Think about what this means. This community of microbes living inside you is actively influencing how you feel, how you think. They can influence your mood, contributing to feelings of anxiety or calm. They can influence your cravings, sending signals that make you want a particular food, often the food they thrive on. They are in a very real way part of the conversation happening inside your head. Your thoughts are not entirely your own. Your moods are not entirely your own. You are a chorus. Scientists have a new name for this. They are starting to call a human or any complex animal or plant a holobiont. Holo means whole or entire. It means we are not a single organism. We are a walking ecosystem, a superorganism. We are a collection of species living in a deeply intricate symbiotic relationship. Your human cells provide the house and the microbial community helps to run it. They manage parts of our immune system, they protect us from actual invaders, and they feed us chemicals we need to be, well, us. This idea of life being built on community, on fusion, goes even deeper than the bacteria in your gut. It goes into every single one of your human cells. Inside almost every cell in your body there are tiny structures called mitochondria. You probably learned about them in school as the powerhouses of the cell. They take the food you eat and the air you breathe and turn it into pure energy, the fuel that allows your heart to beat, your muscles to move, and your brain to think. But mitochondria have the secret. They have their own DNA, completely separate from the main DNA in your cell's nucleus. And the story of why is one of the most incredible events in the history of life. Billions of years ago, our ancient ancestor was just a simple single cell. At some point, this simple cell engulfed a tiny, separate, free-living bacterium. But instead of digesting it, a partnership was formed. The bacterium found a safe home protected from the outside world. And the host cell in return gained access to this bacterium's incredible ability to generate energy. That partnership was so successful that it never ended. That ancient bacterium is the ancestor of every mitochondrion in your body today. You are the product of a fusion, an ancient agreement between two different forms of life that decided to become one. This event may have been the single most important leap that allowed for complex life for us to even exist. So when you sit quietly, what is this self that you feel? What is this I? Our reflection tells us that individuality is not what we thought it was. It is not a fortress separate from the world. Individuality for life as we know it is built from community. It is a pyramid of cooperation. You are an I that is composed of a we. You are an ancient fusion of different life forms, now hosting a new vibrant ecosystem of other life forms, and health suddenly takes on a new meaning. It is not just the health of your human cells, it is the health of the entire ecosystem. It is the balance, the harmony of this entire inner world. You are a galaxy, a universe of life all moving together through space as a single complex breathing whole. You are not an individual, you are a world. We've been traveling through the cosmos across vast scales of space and time. We've looked at the quantum foam and the grand structures of galaxies. We've talked about life, about consciousness, and in all of that we tend to assume one basic thing, the individual. We think of ourselves, our self, as a single contained unit. I am making this decision. I am walking this way. I am in charge of this body. But the deeper we look into the tapestry of nature, the more that simple, comfortable idea of the individual begins to tear. The lines become blurry. The self is perhaps not a fortress, but a crossroads. To understand this, we don't need to look at the stars. We just need to look at the forest floor. Consider a carpenter ant in a tropical rainforest. It should be busy following chemical trails working for its colony. But this one is acting strangely. It has left its companions. It is climbing, moving upwards on a plant stem higher and higher, in a way an ant would never normally do. It seems to be on a mission. It finds a leaf, crawls to a very specific spot, clamps its powerful jaws onto the central vein, and then it stops. It waits. It dies right there, frozen, in a final death grip. This was not the ant's choice. This was not the ant's will. The ant is a victim of a hostile takeover. It has been invaded by a fungus, a type of cordyceps. We call it the zombie ant fungus. The fungal spores infected the ant and the fungus grew inside it. But it didn't just feed on the ant, it seized control. Interestingly, it doesn't seem to infect the ant's brain. It bypasses the brain and takes command of the ant's muscles, turning its body into a puppet. The fungus pilots the ant, forcing it to climb to the perfect height and location, one with the precise temperature and humidity the fungus needs. After the ant bites down and dies, the fungus completes its work. A long stalk erupts from the back of the ant's head, and from this stalk it rains new spores down onto the forest floor, onto the ant's unsuspecting sisters below. The ant was never an ant at the end. It was a vehicle. It was an extension of the fungus's will to survive. This isn't an isolated case. Nature is filled with these invisible controllers, these puppet masters. Let's look at a different relationship, a tiny single-celled parasite called Toxoplasma gondii. This organism has one ultimate goal: it needs to get into the gut of a cat. That is the only place it can sexually reproduce. But it often finds itself in the body of an intermediate host like a rat. How does it bridge the gap? How does it get from the rat to the cat? It hijacks the rat's brain. A healthy rat is programmed with a deep instinctive and very smart fear of cats. If it smells a cat, it hides, it runs. But a rat infected with toxoplasma loses this fear. Its brain chemistry is altered. The parasite rewrites the rat's most basic survival code. In fact, some studies suggest the rat stops fearing the smell of cat urine and instead becomes attracted to it. The parasite turns the rat's runaway signal into a come closer signal. The rat becomes reckless. It wanders into the open drawn to the very predator it should avoid. The cat gets an easy meal, the rat gets eaten, and the parasite wins, having completed its life cycle. In both these cases, the parasite is manipulating the host's behavior. This isn't random. It is a precise, elegant, and terrifyingly effective evolved strategy. The fungus and the parasite are releasing specific chemicals that force the host to act against its own interests, all to ensure the parasite's life cycle continues. This is fascinating and perhaps a little disturbing, but it's just ants and rats, right? It makes you wonder, though. It opens up a difficult philosophical question. How fragile is our own free will? We feel so in charge, we feel like our thoughts are our own. We feel like we are the captains of our ship. But if a simple fungus can so completely pilot an ant, what invisible forces might be piloting us? We are not as simple as we think. Our biology itself is a powerful controller. The ancient programming in our DNA, the script that tells us to seek food, find a mate, and avoid danger, we didn't write that script. It was written by 4 billion years of evolution. Our most profound urges are just echoes of that ancient code. And what about the passengers we carry? Our bodies are not just us. We are home to trillions of microbes. This microbiome, mostly in our gut, is a vast, complex ecosystem. We are just beginning to learn that these tiny organisms are not quiet tenants. They are active. They produce chemicals that enter our bloodstream and reach our brain. We have a gut-brain axis to a constant chemical conversation between our digestive system and our mind. An imbalance in that gut ecosystem is linked to feelings of anxiety and depression. These microbes can influence our moods, our stress levels, and even our food cravings. When you suddenly desperately crave a sugary snack, is that you making a choice? Or is it a colony of yeast in your gut sending out chemical signals demanding to be fed? Who is the self in that moment? And then there are the chemicals we make. Our hormones. We think of love as the highest, most human emotion, but it is also a flood of oxytocin and dopamine. We think of fear as a rational response to danger, but it is also a surge of adrenaline and a cortisol. These chemicals don't just accompany our feelings, they create the physical reality of them. They change how we see the world, how we make decisions. This is not to say we are all zombies, but it is to say that nature is a cold, efficient algorithm. It doesn't care about our concept of the individual, it cares about what works, what survives. The line between self and other is much, much blurrier than we are comfortable with. We are not a fortress isolated from the world. We are a crossroads. We are an ecosystem. We are a collection of voices, our genes, our hormones, our microbes, our culture, our memories, all arguing and cooperating, a complex chorus that rises up to create the symphony we call the self. Is not a static thing. It is a dynamic process, a conversation. And perhaps free will isn't about being free from all influences. Perhaps it's just the name we give to the beautiful, complex, and sometimes parasitic music that emerges from that chaos. For a little while, let's change our focus. We have been looking outward at the almost unimaginable scales of space and time. But there is another fundamental law of the universe that is just as powerful, and it operates on every scale from the birth of the cosmos to the single thought in your mind. It is the law of growth, and it is perhaps the most misunderstood force of all. We can understand this law with a simple thought experiment. Imagine you have a single ordinary piece of paper. It's thin, maybe 1/10 of a millimeter. You fold it in half. Now it's twice as thick. You fold it in half again. Now it's 4 times as thick. You fold it a 3rd time and it's 8 times as thick. This is simple, but this is where our minds begin to fail us. Let's say you could fold it 10 times. How thick would it be? You might guess it's as thick as your thumb. It would actually be about the width of your hand. What if you could fold it 20 times? Now, the paper, which started as a tiny fraction of a millimeter, would be over 100 meters tall. It would be taller than the Statue of Liberty. Let's keep going. We are only at 20 folds. At 30 folds, that same piece of paper would be 100 kilometers high. It would have punched through the atmosphere and be floating in space. This seems impossible. Our intuition screams that this is a trick, but the math is simple. It just doubles and doubles and doubles again. Let's fold it just a few more times. We are aiming for 42 folds. We are not adding, we are multiplying. The power of this repetition is staggering. At 42 folds, that single impossibly thin piece of paper would be thick enough to stretch from the surface of the Earth all the way to the Moon. This concept is called exponential growth. It is the rule of doubling, and it is everywhere. The reason the paper folding problem feels like a riddle is because our brains are not built to understand it. We are linear thinkers. We evolved in a world where effort and reward were directly connected. If you walk for 1 hour, you get twice as far as walking for 30 minutes. If you pick 10 berries, you have 10 more than you had before. Our world is based on addition, 1 + 1 + 1, 1 + 1. But the universe does not always add. Very often it multiplies. A virus is a perfect, terrifying example. One person is infected, they infect 2 others, those 2 infect 4, the 4 infect 8. In the beginning, the numbers are tiny, 1, 2, 4, 8, 16. Seems like nothing. It's a rounding error. It's background noise. Then it becomes 1,000, then 2,000. Then in the same amount of time it becomes 4,000, and then 8,000. Suddenly, in a matter of days, the world is overwhelmed. The growth is not a straight line. It is a curve that rockets straight up. Technology works this way. For decades, computers were a specialized hobby. They got a little better, a little faster. But the power inside them was doubling. The number of transistors on a chip was multiplying. And then, seemingly overnight, the curve went vertical. We suddenly had supercomputers in our pockets that connect us to all human knowledge. Artificial intelligence is doing the same. It is not getting one step smarter every day. Its capabilities are multiplying, folding in on themselves, building new skills on top of old ones at a speed we cannot process. This is the rule. The universe operates exponentially. So what does this mean for us here in our quiet lives? It offers a profound lesson. It is the lesson that complexity is born from simplicity repeated. A magnificent complex human being with a brain capable of understanding the stars begins as a single cell. That cell follows a simple rule divide. It becomes 2, 2 become 4, 4 become 8. This simple repetitive process, this constant folding of life itself, builds a trillion-celled creature. The power of repetition is the universe's greatest secret. We often look for the one big event that will change our lives. The one promotion, the one lottery ticket, the one sudden flash of inspiration. We are looking for the lightning strike, but the universe teaches us to look for the paper fold. It teaches us that small intentional changes, when repeated, accumulate to create results we cannot even imagine. The results are extraordinary in the truest sense of the word. They are outside of our ordinary linear thinking. Reading for 10 minutes every night doesn't feel like much. After one night, you are not smarter. After a week, you've barely finished a chapter. Your brain tells you it's not working. You are thinking linearly, but the knowledge is compounding. It is multiplying. Ideas are connecting. After a year, you have read a dozen books. After a decade, you have built a new mind, saving a tiny amount of money, practicing a single chord on a guitar, writing one sentence, taking one walk. Each action is a single fold. For the first 10-20 folds, the change is invisible. This is the hardest part. This is where we give up. We are 20 folds in and we are still standing on the ground. We can't see the tower we are building. But the law is the law. The doubling continues. This is the quiet magic of accumulation. It is not loud like an explosion. It is the silent, steady, relentless growth of a tree. It is the slow, patient work of water carving a canyon. It is the universe's primary method of creation, hidden in plain sight, available to every one of us. It is the power to fold our intentions over and over until we too can touch the moon. We find the black holes. For the longest time, we thought of them as the universe's final punctuation mark, a full stop. They are the ultimate one-way door. Matter checks in, but it never checks out. Gravity so intense, a grip so total that not even light, the fastest thing we know, can escape once it crosses that invisible fatal boundary, the event horizon. They are the universe's perfect prisons. They just are. They gather mass, they spin, they grow heavier, and they wait. They are cosmic vacuum cleaners that never seem to get full swallowing starlight dust, and entire suns digesting them into a point of infinite density. We looked at these objects and we thought, finally, something permanent. If you wanted to hide a secret, you'd throw it into a black hole. It would be gone truly and completely forever. That was the picture. It was simple, terrifying, and as it turned out, incomplete. The problem with that picture is that the universe seems to run on two different sets of rules, two different operating systems that don't like to talk to each other. On the very large scale, the scale of planets, stars, galaxies, and black holes, we have Einstein's general relativity. This is the majestic theory of gravity as a beautiful curving fabric of space and time. It's elegant, smooth, predictable, and grand. But on the very small scale, the scale of atoms, electrons, and photons, we have quantum mechanics. This world is not smooth or predictable. It is a world of static and chance and probability. It's fuzzy, chaotic, and profoundly weird. Nothing is certain. Things can be in multiple places at once. Particles can pop into and out of existence in a blink. For most of the universe, these two rulebooks stay in their own lanes. Gravity is too weak on the small scale to bother an atom, and quantum fuzziness is too tiny to affect the orbit of a planet. But a black hole is where these two realities collide. A black hole is something unbelievably massive, and that is general relativity's territory. But it's also crammed into a point unbelievably small, and that is quantum mechanics territory. The event horizon, that sharp defined line of no return, is the battlefield. This is where the smooth bending space of Einstein meets the bubbling probabilistic chaos of the quantum world. And this is the stage where the late great Stephen Hawking made his most profound and startling discovery. He decided to ask a simple, brave question. What happens when you apply quantum rules to the edge of a black hole? The answer changed our understanding of forever. It turns out the empty space of the vacuum isn't really empty. At the quantum level, it is a foaming, bubbling sea of energy. And from this energy, particles are constantly borrowing existence. They appear in pairs, a particle and its opposite, an antiparticle. They flash into life, see each other, and then in a fraction of a second they annihilate, disappearing back into the nothingness they came from. They are called virtual particles. They exist on borrowed time, on borrowed energy, and they always pay their debt back instantly. This happens everywhere all the time, in the space between you and this screen and in the vastness of the cosmos. Hawking realized this process must also be happening right at the edge of a black hole's event horizon. Now picture a pair of these virtual particles popping into existence right on that line. In an instant they are born. But what if one particle pops into existence just inside the horizon while its partner pops into existence just outside? The one on the inside is lost. It is immediately captured, pulled into the black hole forever. The one on the outside, however, is now an orphan. It cannot annihilate with its partner. It is suddenly real. It has no debt to repay because its partner took the debt with it into the singularity. So this lone particle escapes flying off into space as a tiny burst of energy. To a distant observer, it would look like the black hole itself just emitted a particle. It would look like a faint, faint glow. But you can't get something from nothing. Physics is the ultimate accountant. The books must be balanced. That escaped particle has real energy. Where did that energy come from? It wasn't stolen from the vacuum because its partner didn't pay the energy back. Hawking showed that the energy must have come from the only place it could come from, the black hole itself. The black hole pays the bill for that escaped particle. Every time this happens, every time a tiny particle escapes, the black hole loses an infinitesimal amount of its own mass and energy. It's as if the black hole is sweating, or more accurately, evaporating. This escaping energy is what we now call Hawking radiation. This is not a fast process. It is agonizingly, unbelievably slow. A black hole the mass of our sun would take a 1 followed by 67 zeros in years to evaporate. That is a number so large it has no useful name. It is billions upon billions upon billions of times longer than the entire current age of the universe. But it is not infinite, and that is the twist that changes everything. The black hole, the ultimate prison, the very icon of forever, has a lifespan. It is not eternal, it too will die. In the unimaginably distant future, long, long after the last stars have burned out and the last galaxies have been scattered into a cold, dark and empty soup, these lonely supermassive black holes will be the only things left. And they will be sitting there silently glowing with this impossibly faint radiation slowly, slowly bleeding their mass away into the dark. They will shrink. Over eras that defy calculation, they will shrink faster and faster as they get smaller until finally the very last giant of the old universe erupts in a final brilliant flash of gamma rays, evaporating completely, gone. What does this tell us? It tells us that permanence is perhaps the grandest illusion of all. We search for things that last for constants for solid ground, but the universe seems to be a story of cycles, not of endpoints. Even the darkness changes, even the void evolves. The one-way door isn't one way after all. It just has a very, very long return policy. Everything it seems is just passing through. We've been on a long journey. Through 12 chapters, 12 explorations of the cosmos and ourselves, we have travelled from the unimaginable inferno of the Big Bang to the quiet inner world of our own biology. We have looked at the code that writes life and the dark invisible structures that hold galaxies together. We have touched the impossibly small quantum world and stared into the infinite expanding universe. We began this journey all that time ago with a question. It's perhaps the oldest question humans have ever asked, whispered around campfires and written into the code of our most complex telescopes. It's a question so simple you can hold it in a single breath, yet so vast it contains everything. What are we? After all we have seen, after all we have uncovered, we must return to that question. We must stand here at the end of our exploration and ask it one more time. If all of this is true, if it is true that every atom in our body, the calcium in our bones, the iron in our blood, was forged in the heart of a star that lived and died billions of years ago, if it is true that we are walking on a planet that is not solid ground but a collection of tectonic plates floating on a sea of molten rock itself, a tiny blue speck in an ocean of dark, empty space, if it is true that the reality we perceive, the solidity of this chair, the colour of the sky is just an interpretation, an electrical storm in our brain trying to make sense of a universe that at its smallest level is only a sea of probabilities and fuzzy uncertain waves, if it is true that our self, our personality, our very moods and desires are not the product of a single isolated mind, but are profoundly shaped and influenced by the trillions of ancient bacteria and microorganisms that live within us, an ecosystem that is more them than us, if it is true that when we look up at the night sky we are not seeing the now, but are looking at ancient history, receiving light from stars that may already be dead, a postcard from a time before our species was even born. If all of this is true, then what are we? The simple answers, the ones we were given as children, feel too small now. To say we are human feels like saying a library is just paper. It is true, but it misses the entire story. We are patterns of stardust. We are the universe's most complex and beautiful arrangement of recycled atoms. We are the part of the cosmos that has woken up a living, breathing, thinking collection of matter that was once scattered across light years. We are the children of the stars and we carry their fire in our DNA. We are minds shaped by microbes. We are not single sovereign entities but walking, talking civilizations. We are a collaboration between our complex brains and the simplest life forms on Earth. We are an ecosystem, a delicate balance of 1 trillion different lives all working together to create the singular experience we call Mshuars. We are creatures bound by time, watching ancient light. We live for a tiny fleeting moment on a geological timescale. Our lives are a gasp, a heartbeat in the long, slow life of the universe. And yet with our minds and our tools we have become time travellers. We can look at the sky and see the past. We can look at the rocks and read the history of our planet. We are organisms trapped in the present, but our consciousness is built to sail on the rivers of then and next. We are the curiosity of the universe. If the cosmos is a vast, silent ocean of energy, physics and matter, then we are the one tiny temporary part of it that has developed the ability to wonder. The universe spent 13.8 billion years existing, and then on this small wet planet it produced a creature that could look back at it and ask, why? We are the universe's way of knowing itself. We are its self-awareness. And this leads us to the final, most profound truth. After all this, we must admit that our knowledge is small. For every single answer we have found, we have uncovered a dozen new, more complicated questions. We have mapped the human genome, but we do not truly understand consciousness. We have measured the echo of the Big Bang, the cosmic microwave background radiation, but we do not know what 95% of the universe, the dark matter and dark energy, is actually made of. Our circle of knowledge is like a tiny flickering campfire in the middle of an infinite dark forest. We can see clearly what is right in front of us, but we are overwhelmingly, profoundly surrounded by the unknown. But this is not a failure. It is not a reason for despair. It is the entire point. The beauty of our existence is not found in having all the answers. The beauty is found in the act of asking. The The wonder is not in the destination but in the journey of continuing to question. That relentless, unquenchable curiosity is the thread that connects us, the small finite human, to the vast infinite cosmos. We are finite beings, but we are capable of asking infinite questions. So as we come to a close, let these vast ideas settle. The stars are still out there burning hydrogen into helium. The atoms in your hand are still spinning a dance of quantum probability. The ancient bacteria are still living within you. The universe continues its slow, majestic and silent dance. And you are part of it. You are not just a spectator, you are a participant, you are the we. So as you rest, as you let your mind drift, do not struggle for an answer. The answer is not the important part. Just feel the weight and the wonder of the question itself. Breathe in, breathe out. You are the stardust, you are the question. Rest now and wonder.